In the vast landscape of industrial food production, there is perhaps no item more scrutinized, more mythologized, and yet more universally consumed than the hot dog. It is an icon of American culture, a symbol of baseball games, backyard cookouts, and street corners from New York to Chicago. Every year, Americans consume an estimated 20 billion hot dogs. That is 70 hot dogs for every person in the country. But behind this ubiquity lies a process that is often shrouded in mystery and urban legend. We have all heard the stories: mystery meat, lips and ears, the infamous pink slime. Today, we strip away the rumors and step onto the sanitized floor of a mega factory to witness the unvarnished scientific truth. This is not just cooking. This is high-velocity protein engineering. Our journey begins at the loading dock of the processing plant. The air here is frigid, kept strictly below 40 degrees Fahrenheit to inhibit the growth of bacteria. Massive semi-trucks back into the sealed bays, unloading pallets of raw material. So what exactly is in a hot dog? Contrary to the terrifying myths of hooves and tails, the primary ingredient in a standard Frankfurter is muscle meat, specifically trimmings. When a cow, pig, or chicken is butchered for the premium cuts we see in the supermarket, the steaks, the chops, the breasts, there are always smaller pieces of high-quality meat left clinging to the bone or the fat. It would be an ecological and economic waste to discard this protein. Instead, it is harvested. For beef and pork, these trimmings are collected and packed into 2,000-pound cardboard bins called combos. They arrive frozen or fresh. But for poultry, chicken, and turkey, the process involves a technology known as Advanced Meat Recovery, or AMR. This is where the term pink slime originated, though the industry prefers the term mechanically separated poultry. The carcasses, after the main cuts are removed, are pushed through high-pressure sieves. The force separates the soft, edible muscle tissue from the bone and cartilage. The resulting product is a fine, paste-like textured meat that looks indeed like a thick pink batter. It is 100% meat, but its structure has been completely altered. The bins of meat, blocks of frozen beef trimmings, and mounds of chicken paste are dumped into the first beast of the factory, the pre-breaker. This is a massive industrial grinder equipped with stainless steel augers the size of tree trunks. As these screws turn with immense torque, they crush the frozen blocks, shattering the ice crystals and tearing the muscle fibers apart. The sound is a low, rhythmic crunching. The meat is forced through a metal plate with large holes, extruding it into thick spaghetti-like strands. This stage is crucial for increasing the surface area of the meat, preparing it for the chemical transformation that is about to occur. The ground meat travels up a conveyor belt, a river of red and pink, and falls into the most critical machine in the entire facility, the bowl chopper, also known as the emulsifier or the silent cutter. This machine operates on principles of fluid dynamics and chemistry. It consists of a large rotating metal bowl and a set of razor-sharp knives spinning at speeds of up to 5,000 revolutions per minute. This is where the hot dog is truly born. It is here that the meat ceases to be meat and becomes an emulsion. But meat alone cannot become a hot dog. It needs help. As the blades roar to life, turning the coarse ground meat into a finer paste, the Spice Master adds the secret ingredients. First and most importantly is salt. In a home kitchen, salt is for flavor. Here, it is a chemical tool. The salt dissolves the proteins in the muscle mite, specifically the myosin and actin. These dissolved proteins become sticky and act as the glue that will hold the fat and water together. Without salt, the hot dog would crumble apart like dry hamburger meat. Next comes the water. But it's not just water. It is often crushed ice. Why ice? Because the friction of the high-speed blades chopping the meat generates immense heat. If the mixture gets too hot during processing, the fat will melt and separate from the protein, breaking the emulsion. The result would be a greasy, grainy sausage. The ice keeps the temperature critically low, ensuring the fat remains suspended within the protein matrix. Then the flavor profile is built. Every brand has a proprietary blend, but the classic Frankfurter taste comes from a specific combination of spices: ground mustard seed for tang, paprika for color and earthiness, garlic powder, white pepper for a subtle heat, and coriander. Sweeteners like corn syrup or dextrose are added to balance the salt and aid in the browning process during cooking. Binders such as potato starch or non-fat dry milk are introduced to help the sausage hold moisture, ensuring that juicy snap when you bite into it. And finally, the most controversial ingredient, sodium nitrite. This is a curing salt. It serves three vital functions. First, it is a potent preservative that prevents the growth of Clostridium botulinum, the deadly bacteria that causes botulism. Second, it contributes to the distinct cured flavor of the hot dog. And third, it reacts with the myoglobin in the meat to fix the color. Without nitrites, a cooked hot dog would be a dull, unappealing gray. With nitrites, it retains that signature pinkish-red hue that consumers identify with freshness. As the chopper spins, the mixture undergoes a physical metamorphosis. The distinct particles of lean meat and white fat disappear. They are pulverized and blended until they form a homogeneous, smooth, light pink batter. It looks less like food and more like construction putty or strawberry soft serve. This is the meat batter. Quality control technicians constantly monitor the viscosity and temperature. They take samples to check the fat-to-protein ratio. The batter must be a perfect emulsion, stable enough to be pumped through pipes, yet firm enough to hold its shape. Once the batch is approved, the batter is dumped into a hopper. But there is one enemy left: I. During the violent chopping process, millions of microscopic air bubbles are trapped in the batter. If left inside, these bubbles would expand during cooking, causing the hot dogs to burst or creating pockets that harbor bacteria and ruin the texture. The batter is fed through a vacuum pump. The machine sucks the air out of the paste, making it dense and solid. Now this pink protein-rich sludge is ready for its final form. It travels through stainless steel pipes overhead, moving like a living organism towards the stuffing hall. The roar of the grinders fades, replaced by the high-speed mechanical hiss of the next stage. We have broken the animal down to its molecular components. We enter the stuffing hall, a room that assaults the senses with speed and motion. The pink meat batter arrives here under pressure, ready to be shaped. This is the domain of the high-speed stuffer linker. But to give a liquid batter a shape, you need a mold. This brings us to the casing. Historically, sausages were stuffed into the cleaned intestines of sheep or pigs. These natural casings are still used for premium hot dogs. They provide that satisfying audible snap when bitten. But for the mass market, where billions of hot dogs are produced, natural casings are too inconsistent and expensive. The solution is the cellulose casing. These are long, clear tubes made from plant fiber, essentially processed cotton or wood pulp. They arrive at the factory as shirred sticks, long tubes that have been scrunched up like the sleeve of a jacket. A single stick, only a foot long, can expand into 100 feet of casing. The machine loads these sticks onto a stainless steel horn. The process is a blur, happening faster than the human eye can track. The pump forces the pink meat batter into the casing. As the tube fills, a mechanical chuck rotates, twisting the casing at precise intervals, usually every 5 or 6 inches. This twisting action creates the links. It transforms a continuous tubed meat into a chain of individual sausages, looking like an endless string of pearls. A single machine can produce up to 700 hot dogs per minute, or over 40,000 per hour. The engineering precision is staggering. Each hot dog must weigh exactly the same, usually 1.6 ounces for a standard bun-length frank. These chains of raw hot dogs are draped automatically onto metal racks or hooks on a moving conveyor. They hang in loops, swaying gently as they travel. At this stage, they are still raw, soft, and pale. To become safe to eat, they must face the fire. The conveyor marches the racks into the massive industrial ovens known as the smokehouse. The smokehouse is a gargantuan stainless steel chamber capable of holding tons of product at once. The doors seal shut with a heavy thud. Inside, the hot dogs undergo a carefully choreographed thermal cycle. It is not as simple as just turning on the heat. The process has stages. First is the reddening phase, where mild heat activates the curing agents, setting the pink color. Next is the drying phase, where humidity is lowered to dry the surface of the casing. This is crucial because smoke does not stick to water. For the smoke flavor to penetrate, the skin must be tacky, not wet. Then comes the smoke. While cheap brands might use a liquid smoke shower, traditional factories generate real smoke by burning hardwood sawdust, hickory, maple, cherry, or mesquite in a friction generator or a burning chamber. The thick, aromatic smoke is pumped into the oven, circulating around the hanging sausages. It permeates the cellulose casing, flavoring the meat and depositing natural antimicrobial compounds on the surface. Finally, the cooking phase. Steam is injected into the chamber to raise the humidity and temperature rapidly. The internal temperature of the hot dog must reach at least 160 degrees Fahrenheit, 71 degrees Celsius. This is the kill step. It destroys any potential pathogens like Listeria, Salmonella, or E. coli, ensuring the product is fully cooked and ready to eat right out of the package. After hours in the heat, the racks emerge. The hot dogs are now firm, plump, and a deep red-brown color. But they are still wrapped in that inedible cellulose casing. It has done its job of shaping the meat during cooking, but now it must go. The hot dogs pass through a chill shower of ice-cold brine. This thermal shock stops the cooking process and, more importantly, causes the meat to shrink slightly. This microscopic shrinkage breaks the bond between the meat and the casing, making it easier to remove. Now we witness the most specialized and satisfying machine in the factory, the automatic peeler. The long chains of cooked sausages are fed into this device. It moves at blinding speed. Sensors align the hot dogs. A tiny razor-sharp blade makes a microscopic slit along the length of the casing, careful not to cut the meat. Then a jet of high-pressure steam or compressed air blasts the casing open. A vacuum system grabs the loose plastic skin and sucks it away into a waste collection tube. The naked, skinless hot dog shoots out the other side. This happens so fast that the machine just looks like a blur of motion. If you inspect a skinless hot dog closely, you might see a faint line running down its length or a slightly textured surface. These are the peeler scars, the only evidence of the casing that once held it. The peeled hot dogs tumble onto a sanitary conveyor belt, rolling and bouncing like rubber. They pass through a final battery of high-tech inspections. Optical laser sorters scan every single dog for length, curvature, and color consistency. If a dog is broken, too short, or has a patch of casing left on it, a jet of air kicks it off the line into a reject bin. The perfect survivors march on to the packaging area. Robotic arms, utilizing pick-and-place delta mechanisms, grab groups of 8 or 10 hot dogs, depending on the brand and the eternal bun count controversy, and place them into thermoformed plastic trays. The trays move to a vacuum sealer. All the air is sucked out and often replaced with a mix of nitrogen and carbon dioxide to prevent oxidation. A top layer of film is heat sealed onto the tray. The packages pass through a heat tunnel to shrink the film tight, creating that familiar vacuum-packed look. Finally, the packages are boxed, palletized, and loaded onto refrigerated trucks. From the moment the raw trimmings arrived to the moment the finished box leaves the dock, only a few hours might have passed. The efficiency is relentless. The hot dog factory is a zero-waste ecosystem where biology meets heavy industry. It takes the irregular, unloved parts of the animal and transforms them into a uniform, shelf-stable, and culturally iconic food source. Whether you view it as a triumph of efficiency or a symbol of processed excess, the engineering behind the humble hot dog is undeniably impressive. It is a product of chemistry, mechanics, and speed, designed to feed a nation that never stops moving.